Hey, hello, welcome to the show. It's me, JP. It's time for JP's product pick of the week. Thanks so much for stopping by. And thank you for catching an error in the link in the YouTube description. I was able to fix that, I think. So you should be able to click from that on over to the product page, which is right there. So if you want to go check out this week's product pick before I even talk about it, you can go to that URL. You can go to that QR code. This show is broadcast live from within the product page, so just scroll down a little bit, you'll see it in there. And the neat thing about the product pick show is that there are no coupon codes required. All you've got to do, if it's something you think you want, is throw it in your cart, and you're going to get it for the discounted price. This week it's 50% off, and we just stocked 100 of them. I see 4 of them have gone into people's carts already. Maximum of 10 per customer, no resellers allowed. But what is this? What is this thing? Well, I'm going to have Lady Ada in a moment tell us about this. Before I do that, I will say, if you're wondering, hey, who's he talking to? Who's in the chat? Who's telling him about broken links and things? Well, that right there, that's our YouTube. No, that's our Discord chat. I'm also keeping an eye on the YouTube chat. So hello, Dave Odessa and Randall Bone for hopping on in on the YouTube chat. And here we have Mouse and Jim Hendrickson and C. Grover and Debo Dog, Tyeth, DCD. Thank you, everyone, for hopping in. There's Jeff and Sneelps. Yes, thank you. Yeah, I pasted something in there and it got glommed onto some text. So I think that's fixed now. But anyway, you slice it. Hey, Sam J. Ohio. We are going to have Lady Ada pop back just a little bit in time. This is a new product that we have this week, and tell us about it. So take it away, Lady Ada.
It's the TRRS Trinkey for assistive technology, shown here with the Xbox. The A, when they press the A button, the A gets typed, and when they press the B button, the B gets typed.
We'll even zoom in now. So it's right here.
Okay, great. Thank you so much. So this is a programmable SAMD21 Trinkey board with a nice USB-A connector. It's got like a reset button, so you can enter in a bootloader. You can program it with Arduino or CircuitPython. There's a little STEM QT port, a NeoPixel, USB-A jack. You can use an adapter if you have a C port. And then most interesting is the TRRS connector with switch on 2 switches on the tip and ring contacts, so that you can detect when it's been plugged in. And a nice mechanical connector as well. And all of the pins from the TRRS jack are connected to analog inputs on the SAMD21. So no matter what kind of assistive tech switches you're using, whether they're like potentiometers or you want to use a splitter to connect multiple buttons, you can connect up to 3 switches or 2 potentiometers, or like 1 potentiometer and 1 switch, because you have 4 contacts and they're fully configurable. And the idea here is that you would be able to reprogram this to customize it with Arduino or CircuitPython. So it doesn't come with like a scripting language or like a desktop program to configure it. It's kind of your, whatever your dream is, you can make it happen. But it's like open source hardware and it's inexpensive. So if you want to make a custom design that uses like cording or maybe uses other I2C sensors for a combination of having AT switches and maybe like a sip and puff sensor, this is a little board that you can very easily get up and running. It's minimal and you plug it right in, so you don't need any extra cables. And with Arduino or CircuitPython, you can very easily program it and configure it, use it with your mobile device, use it with desktop. So hopefully this will make it very easy for people to do AT switch projects without needing like any wiring or like a separate Arduino or cabling or whatever. It's all in one, very compact.
And check out whatever Bill is going to do with this is probably what you want to do with it. So AT makers, this is kind of made for them.
But I think also like anyone who is like, oh, I want to add a switch input, it's like you don't necessarily need to have a AT project for it.
There's get tons of ideas.
I want to just add a switch input, and I want the switch to be made out of like 2 pieces of cardboard with laminated tinfoil.
And if you're in Discord, or I'll just repeat it now so you can hear this. Bill says it can completely emulate the Xbox adaptive controller's input, which makes it super handy. Yeah, So there you go.
Yeah, you can basically, because it's a full SAMD 21, you can have it act like any device. You can have it act like a MIDI device. You can have it, talk to Android or iOS or what have you. It's fully open source and programmable, so a customizable solution. And we're going to publish the files, so you never have to worry about this technology getting discontinued. You'll always be able to make it.
Hey, yes, that's right. This is my product pick of the week this week. It is the TRRS Trinkey. This is an adaptive technology wonder right here. It's like, honey, I shrunk the microcontroller and USB cable and connectors, because that's it. That's the whole thing right there. So the idea behind this is that we have different switches that people use, particularly in assistive technology, such as this foot switch right here. So let's say you've got a need to press a button on a computer and you want to plug that in. Well, this thing on its own actually just has 3 wires on it. I've gone and connected that up into a TRS connector. You actually go through some adapters that we'll talk about. But this sort of thing, if we get the right adapters going, we'll just plug right in, and now you've got it. You've got a switch that will do any kind of USB HID things that you want. And it's pretty exciting. So some of the things that you can do with this, not only is it for USB HID, which means you can emulate a keyboard press or a mouse press, but the TRRS connector, which we'll talk about in detail in a minute, that gives us really 3 connections to signals, and those can be analog or they can be digital. So you can do things like emulate some mouse movements, emulate some button presses on a mouse, emulate things like joysticks and potentiometers, so it can be analog reads like that. And since we've got the 3 of them there, it can be 3 buttons, it can be 2 analog inputs and a digital. So we've got a lot of different configurations we can do. And one of the really nice things is that in the assistive technology world, you tend to use these types of cables right here. So this is a 3.5 millimeter TS, so that's mono, so that's generally the signal and the ground. And by using the adapters that I'll talk about, we can get that plugged into there along with its neighbors and sort of stay inside of that assistive technology world. So let's take a look at a few things. First of all, this is the web page right here, the product page. It's product ID 5954. I'm going to refresh to make sure we still got some in stock. Okay, we got 82 in stock, so if you want to get them, you'll get them at this discounted price, $4.98. Just throw them in your cart. You don't need a coupon code. We also got some links in there underneath the Add to Cart button for some things that you might want to check out. Some of those are pretty useful, such as this breakout right here. I have one of those right here, in fact. Super helpful because that gives us the TRRS, which stands for tip, ring 1, ring 2, and sleeve conductors. Those 4 conductors are broken out to little terminal breakouts there. So you can wire stuff directly into those, especially good for testing to make sure that you have the proper conductors picked for the pins that you're using. We also have, I think, a link to a stereo one, and we've also got these mono plug. I really like these mono plug to alligator clip. That's actually what I've got hooked up to this this big oversized key switch button there. So those are really great. And you can throw that switch just by touching those 2 alligator clips together. Really useful for homemade stuff. Like Lamore said, you could clip that to 2 pieces of aluminum foil that have some sponge or something between them with some holes cut out, and you step on them, you're going to close that conductor. Really good for experimentation, and then you make something a little more permanent later. So the product page has a link here. If you scroll down, you'll see Liz just put out this guide, primary guide, Adafruit TRRS Trinkey, which you'll see right here. And this gives us an overview. You can see it in use right there with some of the, I believe that was a Microsoft and Logitech collaboration on these assistive tech buttons there, which they, put out to use with this thing. This is the Xbox Adaptive Controller, and this allows you to run Xbox and Windows games from this controller, wired or Bluetooth. and it's got a bunch of those mono, most of these are mono connectors for buttons like you see there. A few of them have other tricks up their sleeve using the TRS connector for doing some analog stuff, and there's even some of these that are meant to be TRRS connectors. Let me jump to this. When Limor said that Bill Binko from AT Makers is excited about this because of the USB ports, on the sides of this controller there are two USB ports, and those are meant for joysticks, USB joysticks. So typical flight sticks are kind of big and bulky. If you want to make your own different type of joystick for your own needs, you can plug that into our little TRRS Trinkey, plug that into the side here, and that will act as one of the thumbsticks, because in a lot of modern games you have two analog thumbsticks. So I haven't tried that yet. I think that's how that'll work. That will probably need to be a gamepad, HID gamepad to work there based on the spec. And let's see. So if you take a look at the pinouts here, I said we would talk about these connectors. So this pinout diagram here, let me go to the full-sized one. You will see we've actually got tip switch, ring 1 switch, ring 2, and sleeve. So 1, 2, 3, 4, 5, 6. There's actually 6 connections in there. So some of those are internally shorted until a cable goes in, and then a little metal contact is moved out of the way. So you can do things like detect when a cable is plugged in both into the ring 1 position and to the tip position, which can be useful for some things where, for example, in a lot of audio applications, you don't want pops and noises and things as you plug stuff in. You don't want to blow your headphones out. So these types of little internal switches are pretty common to do things like, hey, let's mute the audio until that cable has been plugged in. So that's something you can detect with those switches. But the ones that you really care about, the tip, ring, sleeve, which are going to break out to essentially 3 signals and a ground. So let me show this one in action that I've put together here. So let me first give you an overview. So what I've got here, this is an iPad, and you can use this HID device with anything that'll allow an on-the-go USB connection. So I'm using one of these little iPad dongles here. So a phone, iPhone, Android phone, tablets, they'll all pretty much work with HID stuff these days. So this will show up as an HID keyboard in the configuration that I have it in. And you can see here, this is a TRRS splitter, and you'll find these are really common in PC sound card for gaming. So any kind of gamer headset that has stereo audio and a microphone is using this TRRS connection. So this one breaks it out into essentially 2 stereo pairs. This one is the tip, ring, and ring, and this one is the tip, ring, and sleeve, I believe. And I've made some diagrams of these that we might put into some of the guides to make it a little clearer. But essentially, this gives us a couple of stereo outputs. This one might as well be a mono, or this one, the microphone one, because these are both connected to the same thing. But this gives us 2. This is a pretty typical stereo to mono splitter that I'm using here. So that I then have going out to 2 different buttons, and then just one of these is going out to a 3rd button. So if I plug that into my iPad here, you'll see the Trinkey lights up. It's got a NeoPixel built on. This is a Cortex M0, so we can run CircuitPython. We can run Arduino on there. We also have a little breakout here for Stemma QT I2C sensors and other add-ons. And in this configuration I'm using it right now, when I press one of these buttons, they are mimicking 3 keyboard presses. I think they're A, O, and Z or something that I set up using this little processing sketch that will just light up some colors here. This happens to be the summon the Italian flag buttons for some reason that I decided to make. But those are the buttons I had, and you can see here these are just pretty standard arcade buttons, and I've clipped on 3 of those little mono connectors onto there. And so that can be for cases where you need to use something like an elbow or a wrist or your head to press something, you might use bigger buttons, might not have fine motor control of fingers. So these types of buttons can be used for pressing things that are just larger, easier to use than your typical keyboard key in this type of application. So the code for this, if you want to take a look, let me see if I can plug this into the computer for a second just to get that code loaded up. There we go. So this is using keypad and digital I/O, and then HID keyboard and HID key code. I'm setting one of those conductors to be the ground. In this case, it's ring 2, just because of how the standards of these adapters work. This is essentially in the West, in the US, this standard has stereo audio, the ground, and then the microphone. It's pretty common. In China, they flip the ground and the microphone. So in this configuration, my third conductor, which is what we call ring 2, that's going to act as my ground. So I'm setting that as an output at false, so that'll be ground. And then I'm setting up 3 of these. So I'm skipping over the tip switch and the ring switch. I'm just using tip, ring, and sleeve for these buttons. I've given them some names. I've given them some key code assignments. You can see I have my NeoPixels lighting up different colors depending on what I press. And then the main thing here is I'm using keypad to watch for button presses and then send out key code presses and releases. So very standard HID keyboard kind of stuff, but you could use this for MIDI, you could use this for gamepad, you can use this for mouse stuff. All of those things will work because this little guy right here just shows up as whatever HID device you ask it to. If we take a look at a different example here, I'm going to plug in different Trinkey. We should see the code update here. So this is the example code that comes in the guide. And one of the neat features of this one, I got to watch where my cursor is because this will, oops, let me put a, there we go. This will press keyboard keys when I plug something in. But one thing you'll notice on this one, I'm just going to sort of plug this little dummy cable in here. Watch my little REPL output there. When I plug this in, if I scroll back up, you'll see the first thing it did was say inserted. So that's a case of using one of the built-in switches that's inside of that jack to detect that a cable's been inserted, and then you can have it do something else. In this case, it's not waiting very long, so if I want to have it kind of hold for a second, then I can get it pushed all the way in before any of those little contacts start getting us false hits. So that's a different example that you can see there, but then once that is connected, we can use the buttons just in the same way. In fact, if I plug in my little button box here to this example, and scroll down, you can see, notice it's inserted, and then I can press, I think this one just has 2 of them called out for the A and the B, like in that example GIF that you saw there. So those are a couple of examples of it in action. And let's see, do we have any questions over in the chat here, or anything I missed? Let me know. Let's see. Can this be used for input and output? Yes. So the pins are connected. If we look back at the pinout diagram here, you'll see these pins, we gave them the nice names in CircuitPython of tip, tip switch, ring 1 switch, ring 2 sleeve. Those are GPIO pins on the ATSAM-D21 Cortex-M0 that are used as either GPIO digital in, digital out, or analog in. So you can, I don't know if you can, you probably PWM as well if you want to do a fake digital on the way out. I don't think those are actual analog outs. I could be wrong on that, but someone in the chat, if you know, let me know. But those excuse me, those can essentially be used for things like potentiometers. I don't have any examples hooked up here. Like we said, Bill Binko should be updating the guide with some examples. If he's not doing a joystick one, I might do a simple joystick one to connect to the Xbox adaptive controller there. So let's see, what else? I want to make sure I didn't miss anything. Yeah, we got the RGB NeoPixel on there that you can just use, can be used for indicator. So again, if you take a look at my example here. Oh, where did my browser go? There we go. I think I have to activate. There we go. You can see this NeoPixel, I'm lighting up white. Oh, I've got those backwards, red and green. I flipped some things around earlier and forgot to fix the NeoPixel colors. But that can be used as sort of a little additional bit of input, a little bit of, or rather output or feedback indicator with that NeoPixel there. And then that Stemma QT port, you can plug other things into it depending on your needs. Let's see, other questions. Andrew Stewart asking, do you know if outputs composite video with the Adafruit composite video library written by Phil Burgess? That's a good question. I don't know. The composite video stuff that I've done was with the ESP32. I can't remember if his might work on an M0, but I'm not sure. And that would be probably not any of those pins, unless one of those is an analog pin, but I think Phil's thing works on the analog output A0, A1, but I'm not sure about that. You might want to ask in the help with projects forum to see if anyone has any ideas about that. Let's see. Hairbrain says the TRRS jacks and cables have notoriously terrible signal integrity. They work okay for analog audio, but as soon as you start trying to send anything faster than 40,000 hertz, you're likely to run into issues. Yeah, so you can see like the primary use case for this is buttons being pressed or analog joysticks and things. So yeah, I don't know if you'd want to use this to try to replace your Ethernet or something like that. Although I think I have seen some TRRS to USB. In fact, even in the TRRS Wikipedia page, they mention that. But that can't be a very high-speed USB application there. Other questions? Oh, here's a nice finish speed test with arcade buttons that Yanis Q7 posted. That looks like very similar buttons. I like that. Very cool. Let's see. So yeah, so Todd says the tip pin is hooked up to a GPIO that has the DAC. So I think it's just a single DAC on the M0, and so you may be able to do some analog stuff with that. So yeah, Todd, if you're determined to make a synthesizer on this, a tiny, tiny synthesizer, that would be amazing. Please do. All right. Yeah, I think that covers the questions. Oh, Aaron Meriwether in YouTube says, did you use the tip switch or the ring switch for that inserted enabled? Yes. Would you, using the tip, have avoided the spurious key presses? Also, yes. And I think the tip switch is the last one. So if your code says ignore everything until the tip switch gets flipped, then you have a really good chance, especially with a little delay, of never seeing those spurious presses. So I think that's why. I think in the example code, for some reason, it's a ring 1 switch that's being used, but I believe if you switch that over to tip, you would then avoid. Essentially, the problem with what people are saying is when one of these plugs goes in to the jack, it touches and makes contacts between multiple conductors along the way in, which is the point of the tip switch, is to avoid doing anything with those shorts until it's time. Thank you. Good question. And yes, I believe in this example here. If you look at CircuitPython Essentials, AT switch example, This example here is the one I was running on that second board. This one is using ring 1 switch, I think. Oh no, it says tip switch, doesn't it? Drive tip low and check tip switch to detect if the cable's inserted. Okay. So that should work. I haven't looked at it closely though, so I may be doing something wrong. And having a little bit of extra time, more than, I put it in pretty slowly, but if you give it more than a quarter second here, then you should be good. All right. Then I think that covers it. Andrew Steer asks, where can I send product creation requests to at Adafruit? You can ask questions during Ask an Engineer. That might be a good time to ask something like that. Unisco 7 is great TRRS Trinkey for sure to use on many projects. Yeah, I think it'll be a really cool one. And Paul Cutler also adds you can use the adafruit.com/contact us webpage to find out more about contacting Adafruit. Okay, I think that's going to do it then. So let's wrap this up, get this thing out of the way, and how about, just so it looks snazzy, we can plug this one in back into my computer. And there we have it. That is my product pick of the week this week. It is the TRRS Trinkey. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Don't forget, if you want to pick some of these up, I think we still have them in stock. Just head over to that URL right there. And we have 53 in stock, so the price will go back up pretty soon after the show. So if you're thinking of getting them, get them now. Otherwise, they'll go back up to the $9.95. All right, thanks everyone, and I will see you next time. Bye-bye.